రాముడా రాముడా నన్నాగం చేసింది రో రాముడా 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 నన్నాగం చేసింది రో రాముడా
ఏంటంత పెద్ద అట్లా తెలుసుకున్నాను. ఈ ముసలోడు తోసేస్తాడు ఏమనంటే ఆయన నన్ను ఏ ముసలోడు అలా తోసేస్తున్నావు?
ఏమయ్యా చూస్తే చదువుకున్న వాళ్ళగా అమ్మాయిల మీద పడతావా? చదువుకున్నావా లేదా?
ఏంటో మాటలు తోసేసి మళ్ళీ తిరిగి మాట్లాడుతావంటే
ఏం చదువుతున్నావయ్యా?
ఇంటర్ సెకండ్ ఇయర్.
ఇంటర్ సెకండ్ ఇయరా? ఇంటర్ సెకండ్ ఇయర్ అయితే ఫస్ట్ ఇయర్ ఇంటర్మీడియట్ పాస్ అయ్యావయ్యా?
ఫస్ట్ క్లాస్.
ఫస్ట్ క్లాస్ అయితే న్యూటన్స్ ఫస్ట్ లా ఎప్పుడైనా చదివావా?
సిక్స్త్ క్లాస్ నుంచి చదువుతూనే ఉన్నా.
ఏది మరి చెప్పు, న్యూటన్స్ ఫస్ట్ లా అది ఎగ్జామ్స్ వరకేనా లేకపోతే ఏమైనా లైఫ్లో అప్లై చేయడం ఉందా? అది లైఫ్కి అప్లై చేస్తే నువ్వు నాతో ఇలా మాట్లాడవు. ఏదో ఒకసారి న్యూటన్స్ ఫస్ట్ లా చెప్పు.
మా టీచర్ ఎప్పుడో చెప్పారు కొన్ని గుర్తులేదు. ఏం చెప్పారు అబ్బా న్యూటన్స్ ఫస్ట్ లా? మా టీచర్ ఏం చెప్పారంటే, hello dear students, how are you all? Today I am going to discuss few things which we observe in our daily life. Generally in our daily life we see this mobile, this remote, this car, like these things. I would like to observe this mobile for some time. You also please observe this mobile, concentrate on this mobile or concentrate on this remote. Let us see some time. Half an hour over. Let us concentrate for one more half an hour. One more half an hour over. See, for the past 1 hour, I am observing these two objects. Is there any change in their positions? Means during the 1 hour, this mobile is at this position only, this remote at this position only. Why? I think it is a trust with respect to this classroom or with respect to this bench. I think it is a trust. Are you sure? Yes, it is a trust. We can conclude that it is a trust with respect to this bench, as there is no change in the position of this mobile with respect to this bench. This mobile is said to be at rest. For example, if you observe this mobile for 2 more days, will there be any change in the position? Yes, you are right. No, because I don't know the reason, but it is a trust. Now, let us see this car. It is in the track. It is under motion. See, it is under motion. It is continuously moving. Of course, this track is very small and I am opposing here, I am doing something here. Otherwise, what happens? If we want to stop this car, if I ask this car to come to rest, let us see what it will do. Hey car, please come to rest. Hey my dear car, please come to rest. Come to rest, come to rest. Is it coming to rest? No. Let us do it again. This car is moving on this track and I request this car to come to rest. Say car, please come to rest. Hey car, please come. It's not listening my words. Means the car is continuously moving. Let us take one more experiment. See, here the car is moving in a straight line. For example, the car is moving like this. I request this car to change its direction. The car is moving in the straight line. I am requesting the car to change the direction. Hey car, please take left, take left, take. It's not taking left. Hey car, please take right, right, right. It's not taking right. It's not listening my words. I request this mobile to change its position. Hey mobile, please move from here to here. Please, 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 please move from here to here. It's not listening my words. When they are not listening to our words, we have to use our hands. Remember this. Let us see whether it moves or not now. Hey, mobile, move from here to here. It's not moving? Now it's moving. Now it got displaced. It is moving now. I request it to stop. I'll do if it is not stop. Yeah, it is not stopping. I applied something. Now it came to rest. I applied something. That's why it came to rest. I applied something because of which the one which is in rest is coming to motion. The one which is in rest coming to motion. The one which is in motion coming to rest. If I apply something. If I apply something, the one which is in rest coming to motion. If I apply something, the one which is in rest coming to motion. Even if apply something, it will change its direction also. Let's see. Hey car, take right turn. Yes, now it is taking right turn. See. If I apply force here, what it will do? It will take its, it will change its direction. Otherwise, it will move in the straight line. If I apply some force like this, it will change its direction. Means here we have observed three phenomena. One is the one which is at rest, and the second one is in uniform motion, which is in uniform motion, and third one is direction. Three aspects are there. So the body which is in rest position remains in rest state, which is in uniform motion remains in the uniform motion, which is moving in the straight line will not change its direction. But by applying something, the body which is in rest can come to motion, the body which is in motion can come to rest, the body which is in moving in a straight line can change its direction by applying something. What is that something? Tell me. I have applied something. You have seen what I have applied. That something is called as force. That something is called as force. So, if I apply force, the body which is in rest can come to motion, the body which is in motion can come to rest, the body which is moving in a straight line can change its direction. Otherwise, what happens? Let us discuss its converse, reverse. The body which is in rest remains in rest. The body which is moving with uniform motion will be in uniform motion, constant uniform motion. And the body which is moving in a straight line will continue to move in its straight line. It is a regular observation, right? Is physics required for this? Is any classroom required for this? Any common man can say all these things, right? So all these are common words. But we are studying all these things in our classroom and we are feeling that all these things are very, very difficult. What is difficult in this? It's a very common word we are discussing here. I hope you understood. But my grandfather Newton invented this or stated this, and that's why we call it as Newton's first law. Is this name required? Newton? I think it's not necessary because every one of us know it. But we are not saying he said this and he named it on his name. That is Newton's first law. Now, can you define Newton's first law? The state of the object remains constant until and unless an external force acted on it. That's the Newton's first law. Means the body which is in state of rest remains at rest. The body which is moving in uniform motion remains in uniform motion. The body which is moving in a straight line will move with the constant straight line. That's all. This is the Newton's first law. So I hope you understood about it. Now we have some more information. We can extract some more information with this Newton's first law. See, the body which is at remains its rest only. Here I have defined about force. Now I am discussing about the nature of the object. Till now I have discussed about the Newton's first law and the nature of force and what a force can do. Now I am discussing about the nature of the object. Now my hero is our object. Can you tell me about this object? What it can do and what it can't do? If I apply force, it can move. If I don't apply force, it can't move. Means it can't change its state by itself. If it is at rest, remains at rest. If it is under motion, remains under motion. It can't change its state. This is its nature. This property of this object is known as inertia. What is inertia? This is inertia. What is inertia? The property of the body or the nature of the body by which it can't change its state is known as inertia. Means the body which is in rest remains in rest. It can't change its state from rest to motion. The body which is in motion can't change its state, which is in state of motion remains in motion. The property, when the object is moving in a straight line, it continuously moves in a straight line. It can't change its direction. So this is the property of the body, and this property is called as inertia. The inability of the body to change its state. It can't change its state. The inability is known as inertia. So today let us discuss something more about this inertia. Now let us see the types of inertia. That is, as we have three states: direction, motion and rest. We have three types of inertia. One is inertia of rest, inertia of motion, inertia of direction. Inertia of rest, the name itself saying that the body which is in the state of rest remains at rest. The body which is in the state of rest remains in the state of rest. That's all. We see many cases in our regular life. Let us discuss some examples for this. First one I have explained about this mobile. Cut. See, we have cut. See, we see this mobile. Cut. We saw this mobile. See, this is in the state of rest. As we have observed for the past 2 days, it was at rest. It can't change its state from its state of rest to motion by itself. That's why we say that the body is at inertia of rest. Example number 2. See, I am going to do a small experiment. See this. There is a paper just under the mobile. If I pull the paper slowly, let us see what happens. Hey, the mobile is moving. The mobile is moving. Now see, I'll pull this paper gently and let us see what happens. Guess what happens? If I pull the paper gently, the mobile moves very fast and the mobile will fall here and the screen will be damaged. No problem. 1, 2, 3 and see now. The paper is in my hand. The mobile is there itself. Its position is not changed. Means the body is in rest position only. it couldn't change its state of rest to motion even due to the sudden application of force. This is second example. Let us see one more example. In the morning, what do you do? Or after bath, what do we do? We simply give a jerk to our towel or to our blanket. If I give a jerk to my blanket or towel like this, what happens? You can see some water droplets come out, or the dust particles come out of the blanket. How? How it is possible? If this is a blanket and these are dust particles, they are mixed with the blanket in the earlier case. But at the moment when I give a sudden jerk, what happens? The blanket comes back and the dust particles remain at the same position. Due to the gravitational pull, they will be moving downwards, and thus the dust particles will be separated from the blanket. I hope you have observed this. Otherwise, try it at your home once. And one more example I would like to give for this inertia of rest, that is mango tree. For example, there are several mangoes to the tree. If one mango is cut, there are several mangoes in the tree. You want one mango. What do you do? You may hit with a stick, otherwise you may shake the branch. Okay? If you shake the branch, mangoes will fall down. How? The moment when you give jerk to the branch comes down and the mango remains at that position only, and that's how it will be separated from the branch. This is also due to the inertia of rest of the mango. And one more popular example I would like to give, that is, for example, assume that you are in a bus. You are standing in the bus. The bus suddenly starts. What happens? If the bus suddenly starts, what happens? Yes, you are right. You fall backward. Why? The bus is moving. Your feet in touch with the bus are at motion. Because the bus is moving, your feet moving, but your body remains at rest. So, your feet are moving forward and body is at rest. You are not actually moving backwards. Everybody say that you are moving backwards. No, that's wrong. Your feet actually moving forward. Hence, you feel that you are falling backwards. So, obviously, it is nothing but you are moving backwards. But what actually happened? The bus is moving. Your feet are in touch with the bus. The feet are moving in the forward direction. Your body is still at rest position. It can't change its state by itself suddenly from rest to motion. That's why it is at rest. Your feet are moving. You are at rest. Means you are leaning in the backward direction. These are some popular examples for the inertia of rest. I feel happy if you can share some examples with me. Click on the chat button and whatever the inertia of rest you have experienced in your life, can share with me. Now let us discuss about the inertia of motion. The name itself saying that what is inertia of motion. The body which is in motion, remains in motion, it can't come to rest. That is the inertia of motion. So let me give you some regular examples which we experience. The most popular example is when a person is traveling by a bus. The bus is moving with certain speed and the driver sees a crossing the bus. He suddenly applies the brakes. What happens if the driver suddenly applies the brakes? All the passengers fall forward. Why? As you are inside the bus, your feet are inside the bus. The feet are in motion with the bus and your body is also in motion along with the bus. The moment when the driver applies brakes, what happens? The bus comes to rest, feet which are in contact with the bus comes to rest. Feet are at rest, but your body is under motion. It can't come to rest by itself instantly. That's why your body is moving, your feet are at rest. That's why you feel that you are you feel, you move forward, you fall forward. Is it clear? So this is one beautiful example for inertia for motion. One more example I would like to give, that is, in city buses, generally we see our students jump from a running bus. What happens if a person jumps from a running bus and stops at that moment, at that place itself, without moving forward? What happens? The moment when he jumps from the bus is in motion, he is in contact with the bus, so he is in motion. The moment when he jumps, his feet touch the ground is at rest. His feet comes to rest, but the body is in motion. That's why his feet come to rest, the body moves forward, that's why he falls. So as to avoid that, what you do, you're a student, what you do? You run along with the bus for some time and slowly you bring your body to rest. So this is how you can save yourself. This is one more example for inertia of motion. Any more examples for inertia of motion? Yeah, you try and you can tell me by chat button. I'll be waiting for your answers. Now let us see inertia of direction. Again, imagine that you are in a bus and passing through some ghat roads, which are like this, like this, like this, like this. If you go through by some ghat roads, if you go to Tirupati or somewhere on the ghat roads, assume that you are sitting inside the bus driver suddenly takes a right turn. If the driver suddenly takes a right turn, what about the passengers? All the passengers move towards the left. Have you ever experienced? Again, if the bus driver takes a left turn, what happens? What about the passengers? You are a passenger. What about the passengers? All the passengers move towards the right. So this is inertia of direction. Means if the bus is moving in the straight line, you are in the straight line, your body is tend to move in the straight line. The moment when the bus takes a left turn, the bus is actually moving towards left, your body is at rest. That's why with reference to the bus, your body is moving towards the right. If the bus is taking a right turn, the bus is moving towards right, your body is at rest. With reference to the bus, your body is moving towards the left. So this is one more example for inertia of direction. So hope it is clear. In our material, we gave some more examples for inertia of rest, motion and direction. Go through them. It is very easy. And next, let us discuss about Newton's second law. See you in the next class.